Hello, dear students. In this lesson, we are going to talk about prime factor decomposition. Prime factorization is a method in which we express a number as a product of its prime factors. It's also called the fundamental theorem of arithmetic. We simply need to learn it in such a way that we simply have to break down a number. Let's say we have a 30, so we can break it as 5 times 6. Though we have broken into two parts, but students, you see that though 5 is a prime number, but 6 is not a prime number. So we have to further break down this 6 in its prime factors. So that's what we'll have to learn. There are different methods of doing prime factorization, and we'll be doing that. So 6 can further be broken down, and we get 2 times 3. So overall, 30 can be written as product of 2 times 3 times 5. There are mainly two methods that we often use to perform prime factorization. The one method is the factor tree method, and the other method we have is prime factorization method by division method. We'll first focus on factor tree method. Look at a number. Suppose we have to factorize 60. And what we do, initially we simply think of two simpler number that can give 60 after multiplication. It's not essential that you always choose these two numbers only. It's up to you. You could have even chosen 12 times 5. That would have still given 60 after multiplication. So it's up to you which two numbers initially you start with. And obviously 10 and 6 are not the prime numbers. So we have to further break them down. So 10 can be further broken down as 2 times 5, as you know that 2 times 5 is 10. And now, yes, 2 as well as 5, they both are the prime numbers, so we don't have to further factorize it anymore. However, 6 is still not a prime number, so we have to again break it. And again, you know that 6 is a product of 2 and 3. So this is how, after breaking 6 as 2 and 3, we have got other pair of two prime numbers. So basically, we are done now. We have got 2, 5, 2, and 3. It's a good habit to start writing the numbers in the ascending order. So we have two twos, one 3, and one 5. This is how we can represent our 60 as a product of 2 times 2 times 3 times 5. The other method of doing that is when we have multiple similar prime factors, rather than writing them so many times, we can simply use an exponential notation or index notation. So this is how we can represent our 60 in its prime factored form. Let's have a few more examples. Let's begin with 850. So you guys can clearly notice that 850 can be broken down into simpler numbers. Let's say 10 times 85 because a 0 is there, so it's obvious and it's easier to break it into 10 and 85. Now further, 10 can be broken down as its prime factors of 2 and 5. And you know that these numbers are prime numbers, so we don't have to further break them down. However, we have to break 85. So we have to think of two numbers that can uh, give you 85 after multiplication. So just because 5 is at the end, we can obviously consider 5 uh, as one of the factor. To get the other number, if you know the times table of 17, you must be knowing, or else you can even perform division. Then too you can cross check. So yes, we have got one number as 5, other is 17. And now you notice even 17 is also a prime number. So we have to stop here. So we can represent our 850 as the product of 2 times 5 times 5 times 17. Alternatively, we can even represent 5 in the exponential form, which is 5 raised to the power of 2. And this is how we have just represented 850 in its prime factored form, or its Prime factorization is 2 times 5 times 17. Let us now continue with the next example. We can have 488. Now it looks a little critical number, not very difficult, but sometimes if you don't have the idea of multiplication or times table, you might struggle, but don't worry. As you notice, it's an even number, so obviously you can start with 2. That's still okay. If you can't guess other two bigger numbers, we can simply start with 2, or even 4 is also a good choice to start with, because you can notice that all the three digits are divisible by 4. Let's begin with 4, and obviously 4 is not a prime number, so we'll have to further break it down. But before that, let's now divide 4 into this number. We get 122. Now they both are the composite numbers. Basically, the numbers which are not prime are called composite numbers except one. One is neither prime nor composite. So you have to take care of that. Well, after breaking down 4, we get 2 and 2s. We'll have to stop here. However, we have to continue with 122. Now again, 122. Let's begin with 2. That's a simpler number. And as we divide it by 2, we get 61. Okay, so this is how we've got even 61 itself is a prime number. So we don't have to do anything else after that. We can simply represent our 488 as 2 times 2 times 2 times 61, or we can write it as 2 raised to the power of 3 times 61. That's it in this question. Let's continue with the next method of prime factorization, which is the division method. In this method, rather than considering two numbers at the beginning, we simply start with the least prime number that can divide the given number. As you notice, we have to get prime factors of 60. So what we do, we think of the number which can be divided in 60, and that's the least prime number. So obviously it's 2. Once you divide 2 in 60, you don't have to write anything else except quotient. So you write 30 as the quotient here. Now again you think of the number that can further divide this 30, and it has to be a prime number. This is the essential condition in this method, that whatever divisors you choose, they have to be prime numbers. You cannot do it with a non-prime or a composite number. So this is what you have to take care of. Well, again 30 is further divisible by 2. We got 15. Once we got 15, 15 is no more divisible by 3 because it's an odd, sorry, 15 is not divisible by 2 because it's an odd number. So we think of the next prime number. As we divide 3 by 15, we get 5. As soon as we get 5, again, even it's not divisible by 3 anymore. And we can't even think of 4 because 4 is not a prime number. So we can never divide the number by 4 in this method because 4 is not a prime number. Well, 5 itself is a prime number, and yes, that's where we stop. So once we get 1, we have to stop, and that many factors that we got here, basically these divisors we got, and obviously these are the prime numbers. So we can write them in the form of product. So 60 is equal to 2 times 2 times 3 times 5. Or else we write 2 squared times 3 times 5. This is the simple way of performing prime factorization using the division method. Let's have a few more examples so that you get the better understanding. To get prime factors of 2100, we do the same thing. We simply draw a bar like this, and this is the simple format in which we do. And you know that this is an even number, so obviously it's divisible by 2. So the least prime number is always 2, and because 1 is neither prime nor composite, so if we have to think of the least prime number, it's obviously 2. So 2 times 1 is 2. Now, don't say that 5. No, it's not 5. Why? Because as you take 1, that's not sufficient. And as soon as you have taken the next number, immediately you have to add a 0 here. That's what we do in long division. But here we have to do it a bit faster, so we do it in this way. So 2 times 5 is 10, and now 2 times 0 is just 0. Basically, we just, right? Or you can say half of 2100 is 1050. That's not a good habit of doing that in this way, but yeah, just for understanding in that case. Well, after that, again, it's an even number. You can further divide it by 2. So, you know that at the beginning, yes, you can take more than one number because even if you add a 0, it won't affect that, right? So it's useless to write a 0 at the beginning. 2 times 5 is 10, 2 times 4 is, sorry, it's 2 times 2 is 4, and then 2 times 5 is 10. Now, students, as you notice, this number is an odd number, so obviously it's not divisible by 2. We think of the next number, which has to be a prime, so which is 3. Let's think of 3. Now, the divisibility test of 3 says that if we add all the digits and it comes in the times table of 3, yes, it comes because it's 12 and it comes in the times table of 3. So the entire number must also be divisible by 3. So definitely we can go with 3. And as we divide it by 3, let's see what we get. 3 times 1 is 3. Now 2 is remainder, 22. 3 times 7 is 21. 1 is remainder and 5, 15. 3 5s are 15. If you find it difficult to do in this way, you could have checked it in that way. Like once you are aware of long division, it can be done. Once you practice, you will use two of that, and it's very easy to do in this way. Well, three ones are three like this. You could have considered. Then you wrote two. Then you noted down two. Three sevens are 21. You noted down one and five. So the same thing I did here. So rather than showing these many steps, you simply have to write down the quotient here. That's why the process is a little faster. Well, again, let's see if we can further divide it by 3 or not. So we have to further check the sum of the three digits. And I guess it's not gonna be divided by 3 because now 13 is not divisible by 3. So we think of the next number. Shall we think of 4? Not at all, because 4 is not a prime number. And yes, 5 can easily divide because that ends with 5 only. So we just divide by 5, 5 times 3 is 15, 5 times, then 2, 25, 5 times 5 is 25. Further, we can divide by 5, we get 7, and you know that 7 itself is a prime number. We simply divide by 7. So now we can write our 2100 as a product of these many prime factors. I'm going to write directly in the exponential form. 2 squared times 3 times 5 squared times 7. Let's continue with the next example. Again, we have to start performing division as it's clearly visible that it's not divisible by 2 because it's an odd number. We may think of 3, yes, it's divisible by 3. 3 2s are 6, 3 3s are 9, and 3 1s are 3. Now, further again, it's divisible by 3. 3 times 7 is 21, 3 times 7 is 21. Now, it's no more divisible by 3, neither 3 nor 5. Yeah, it's 7. 7 can divide this. We get 11, and 11 itself is a prime number. Once we get 1, we have to stop. The 693 can be written as a product of its prime factors, which is 3 times 3 times 7 times 11. Okay, students, so that's it in this lesson. See you in the next lesson. Bye bye.